Welcome to Desk
Hey everybody, happy Taco Tuesday.
It is Taco Tuesday.
It's me, Lady Ada. I had some tacos. Time for Desk Ada. With me is Mr. Lady Ada.
Hello.
You're a little hidden. You don't have a camera on you today, but that's okay.
No one actually wants to see me anymore.
No, you're just like a skunk bear. Okay, so we got a show because I did a blog post like last night at 3 in the morning that I sent to you, and you blogged this morning. Thank you for blogging. You know how to blog.
I know how to blog.
That's your job. And it was about this new chip that was announced yesterday. Wow.
I can blog.
Do you want to talk about this chip?
Yeah, we got a bunch of stuff going on here. So this is the ATmega SAMD51 M4 series. It has some stuff on it that you like.
This is nice. I'm gonna pet it.
Yeah.
Yeah, it's SAMD51J. You can tell this was done. This was wrapped up before the Microchip merger completion. And you took this photo with your camera. Thank you.
Yeah, this was with I have a little macro lens for my iPhone, which is surprisingly good.
Yeah, I'm excited about this chip. Usually I don't get into chips during release. The last time I was this excited about a chip release was the AT90 S1200. I had an engineer sample of that. Or no, sorry, the ATtiny 2313, which was the successor to the AT90 S120. And so I really like this chip because this is actually, you were there actually, it was at one Maker Faire ago when I was talking to
Bob
Martin and some Microchip folks, and I said, you know, we're doing CircuitPython. We just started CircuitPython, and I was like, well, you know, we're fitting it onto the SAMD51, which is this Cortex M0 chip, has, you know, 256K of flash, 32K of RAM, and we're like, it's kind of working, but I think I'm going to run out of memory, and I'm going to run out of speed, because the MicroPython, which is what we based off of, usually runs at like 1 megabyte of flash, 100K of RAM, you know, half a megabyte of flash, or, you know, 100 megahertz or whatever. And I was like, I really like the SAMD21 because it's in the Arduino 0. We've been using it in the Feather line very successfully. Metro M0. We have, you know, now we even have a Gemma M0. We have a Trinket M0 coming out.
Yeah, we just released this. We
like this Cortex M0 chip. It's pretty sweet. Very fast. Like it's basically the same price as an ATmega 32, but it's like full processor with a lot of power. But we wanted something a little bit more. We're like, look, you know, we want something with floating point, DSP, Cortex M3 or M4 with more oomph, because, well, with Arduino you don't really need it so much, but with Python it does help because, you know, you're interpreting and you need a lot of RAM to hold your objects, and you need flash to store all your library code. And they're like, well, there's something coming out. We can't talk about it yet, but like email us in a couple months. And so I emailed like around January maybe, or like February. And they said, oh, you know, if you sign this NDA, we can give you a data sheet and some samples. And so it took a couple months, but I did. I got some samples in March maybe, or April, May.
Yeah.
And we put together a couple boards with this really cool chip, and it was only announced yesterday, so we can finally talk about it publicly. Yeah. So like people are like, what's this Feather M4 or Metro M4? Like I see folders or files.
And it runs.
It will run.
will run.
Will run. We have to port ASF4
Working
because
on
they
it.
changed this substructure, but it's something Scott's working on.
Yeah.
And it's going to be for CircuitPython. Right now we only have Arduino working for it.
We'll get there.
But we got that pretty much going, almost completely.
Yeah.
And then CircuitPython will probably take us. The chips aren't even like fully available. It's announced, but not like 100% available. And then as they get more popular, we'll make boards and ship them, and maybe people will help us with porting like more Arduino libraries and stuff. It's almost the same chip as the SAMD51, but it's actually just bigger. Like the peripherals are very similar. So I thought, if you want, we could go to like the page and look at some options for this chip.
Yeah, we're there.
Okay, so we're here. So let's look at the data sheet, which is 10 megabytes. It's huge. So you can download this. Do you want to hide me? Because I'm not.
Yeah, I'm gonna move your underwear.
So this is 32-bit ARM Cortex M4F. The F stands for
Fast?
floating point unit.
Oh.
And 1 megasample per second ADC. I don't know exactly why, like, that's a huge deal, but that's kind of the huge deal. It has dual 1 megasample per second 12-bit ADC. Has QSPI, so you can like store stuff on SPI flash and access it very quickly. USB. There's an Ethernet version. It has capacitive touch.
Let me just say something.
Yeah.
This data sheet is 1,731 pages.
Yeah, they do good documentation. I don't know. There's one thing that you're not going to lack is documentation. It's all there. You just have to find it. Runs at 120 megahertz. Although, it's interesting when we connect with our Sega J-Link.
Yeah.
Through ML Studio, it says 150 megahertz max. So I think you can overclock this.
We're absolutely going to overclock it.
Huh?
We're absolutely going to
We're going to totally overclock it.
Yeah.
Why not? We run it at 200 megahertz. Has all the debug stuff, floating point unit. There's multiple versions. There's 256K, 512K, and 1 megabyte flash, and then 128, 192, 256 RAM. So it's like you get a lot more no matter what, although RAM is the big thing that they bumped up. And then there's like extra RAM too, or there's some like RAM correction code stuff. There's some like SRAM that I guess is in a backup mode. I don't know what that is. All the interrupts, serial debug, power supply modes. Oh, one thing that's really interesting is there's like a buck converter built in. So the core for these ARM Cortex chips runs at 1.8 volts, but usually your VDD/IO is 3.3, or at least that's why I do. I run it at 3.3 volts, and inside there's a linear regulator. Well, this chip actually has a little buck converter that you can use. It has a linear regulator, or you can use a buck converter. It probably saves you like a couple of milliamps. It might make a difference when you're in like super low power mode. So that's kind of nice. It's like built-in buck converter on the fly. You can on the fly select between the two. Has DMA, has a direct SD card memory access at high speed, so you can, if you want like to, not like SPI mode, but like direct SDIO access, you can do that. QSPI, I don't know if it's like you can store, it says execute in place, can you like store like flash data in there? I don't know. Has Ethernet on the E series, I don't really care about that. Has a Mac, you still need a PHY, so I don't know, whatever. USB full speed, has host and device, 8 endpoints, has transceiver built in. Peripherals has like I2C, SPI, more SPI, LIN, RS45, timers, real-time clock, watchdog timer, CRC generator, 2 I2S devices, a position decoder, so it's like a hardware rotary encoder support. Dual, so this is, I guess, it is kind of fun. You get dual 12-bit, 1 megasample per second ADC, 16 channels each, so you can do stereo input and you sample at the same time. So you can you can do high speed sampling, and because you have a floating point unit and you have DSP, because it's a Cortex M4 has a DSP instruction set, you can actually do some pretty serious analog input filter, and then you can actually do digital output as well. Dual 1 megasample DAC, which is kind of nice too, so like stereo. One of the things I want to do is, this chip is fast enough. You know what's funny, like my first computer was a Pentium 120, and now like I'm getting some microcontroller for 120 megahertz.
Yeah.
Kind of insane, but you can decode MP3s natively. So having this do MP3 decoding Yeah, it'll take up some
And-
of time, but then you'd have stereo out.
In
And
the
it's legal.
latest 2600, we talk about this because MP3 patent's over,
It's so we can do it.
so we can do it.
We
It's
can
on
do it.
chip.
I can distribute chips.
And you don't have
Yeah.
to pay $1 or $2.
So sound effects, sound filtering, audio stuff. I'm not like a huge audio person, but I definitely like the idea of being able to play MP3s, from a flash chip or from an SD card natively without having to get like a separate VS 1053. Not that it's like, those are useful, but like if you can do it on chip, oftentimes, if you're doing MP3 you're decoding, you're not going to be doing a ton of other stuff. If you're doing NeoPixels, you can DMA them, maybe some of the the flash management and reading data off of the SPI flash you can do with DMA, and then you'd spend a lot of your cycles doing decoding, but it's still a pretty cool hack, and especially if you have stereo out at 1 megasample per second. Also do like I said, like a lot of scientific analysis. You can like grab data so quickly, filter it, and send it back out. Could be good for like audio filters. There's a temperature sensor built in. That's nothing new. There's this parallel capture controller, which is kind of interesting. So if you, there's like the JPEG cameras, but if you get a raw camera module, it's 8-bit RGB data in with like sync and data enable and clock. So this basically allows you to get raw video in on an 8-bit bus. And the 8-bit, the 8 bits is like 8 red, 8 green, 8 blue, and it kind of filters, and then you do all of them in order. So this has the ability to do PCC, parallel capture controller. You can only use a set number of pins, but you can hook that to a camera and you can do like raw camera reads. And this, again, it's fast enough. It has DSP. You can do like video filtering, not like hardcore video, but maybe like QVGA or something on the fly. Same peripheral touch controller. It has a bunch of crypto stuff built in: AES, True Random Number Generator, public key cryptography library, which probably uses the floating point or DSP core to optimize it. Looks like you can do SHA-1, SHA-256 with DMA assist, so you can stream data through encrypted or hash it. Probably good for if you're doing Ethernet and you want to do like SSL or something, or you're doing Wi-Fi or some other radio and you want to have encryption on the fly. This will do ya. And it's nice because you don't have to use all your processor cycles. And then crystals. Phase lock loop, and then you can drive things up to 200 megahertz. Another nice thing about this compared to the SAMD51 is it comes with a lot of pins. So it comes in a small 48-pin QFN, which is really quite small for a chip this powerful. But it's actually looking and comparing to other chips in other families, STM and Kinetis, and a lot of them, it's like if you want something with this much flash or RAM, you had to get like in the BGA like really big chips. Like physically, they're quite large because they're like, look, if you're going to give you this processor power, we're going to give you 100 pins. But these, like for example, this is the 64-pin QFN. It's not that big, and there's a TQFP version as well, so you can solder it. It's not like a dip chip or SOIC.
On the Metro.
Yeah, this is out on the Metro, and the reason I went with a 64-pin is I wanted to.
This goes on the Feather.
Yeah, there's a Feather version, so it's almost drop-in compatible. The SAMD51, the 48 QFN, which is what we use on the Feather and the Metro. But I bumped up the version on the Metro to be a 68-pin. And then it just goes into like, unending data sheet for like ridiculous. And then, you can choose, there's different combos. You can have, one with 1 megabyte of flash and 256K of RAM, or half a mega flash and 192K of RAM, or like all the way down to 256 and 128. So you can, range up and down depending on how much you want to pay. And of course, the bigger packages tend to have more flash and more RAM. Which is kind of neat because I want to make like a mega version, like an Arduino mega sized, which is, which will run CircuitPython and have like 80 pins. I thought that would be kind of cool.
That'd be neat.
That'd be cool. So this is a neat chip. And so I'm really excited because I was really hitting this like SAMD21. Like it works, circuit.
SAMD51.
Yeah. So I was hitting, not like hitting the limits, but it's like we were definitely feeling like, wow, it would be great to have, a step up from the 21. With CircuitPython. And one of the things I also really like is it's really well priced. And I put this in the article, but
I got the pricing.
yeah, like it's pretty good. Like Microchip got pretty aggressive here. So the SAMD21 G18, which is 48-pin QFN.
What are they competing with? Like the STMs or like what's got?
They're competing with everybody.
Everybody.
So I think this is their first Cortex M0 that I think is really meant for people to use. and it seems very usable. Like if they have the same peripherals as the SAMD51, this peripherals work great. The timers work great. Never had a problem. The Circoms, I2C, SPI, everything worked quite well with the UART. Never had any issues with this peripherals.
At Adafruit, instead of bug reports, we do hug reports every Friday. There's probably someone from Microchip, formerly known as ATmel, I was told.
Phil, I don't know if you know.
I don't know if I knew. Anyways, who did a really good job with this? What do you like about this? Who's the shout out? Who's the hug report you want to?
This peripheral's really good. I like the Circoms. The
Okay.
reason I like the Circoms is there's always been this like annoyance with, you have like a fixed number of I2C, fixed number of SPI, and like the pins are fixed. And what's nice about the Circoms is they kind of were like, they kind of borrowed a little bit from the ATtiny series where they had this USI, this universal serial module, and they're like, look, I2C, like UART, SPI, and I2C is like kind of the same. So let's have the same kind of module, and you can like change pins around, and we'll give you 6. So like you have a lot of flexibility. If you want 2 hardware UARTs, you can do it, and you can put them on almost any pin. Not every pin, but like nearly every pin. And then same with the I2C, you have a lot of flexibility where you want multiple SPIs, you can do that too. And then if like you really need, you can have like 4 I2Cs or like 3 hardware UARTs, and they're very easy to set up. So like you can just generate them whenever you want. So we have a guide on how to do that. And I do all the time whenever I'm like, like for example on the Circuit Playground Express, I have 2 I2C ports. One is for the internal accelerometer and one is external on the pads. And like I have the flexibility of like, turning them around. Also on the Gemma, I have 2 pads that I switch. You can switch between I2C and serial. And the Circom lets you do that. You just tell it like dynamically, like on compile, which one you want, and it just gives you those. And I like it a lot. I'm into that kind of peripheral management. Timers are also really good. Like Phil B just did a really cool NeoPixel DMA thing with timers, and the waveform generator. Anyway, so it's all good. And it's pretty cheap. So yeah, like I was comparing the prices. So like if you compare it to the STM32 405. So it's actually using the Pi board, which is like kind of what I was aiming for, because I was like, I want something almost as fast as that. So this chip is 168 megahertz, up to a megabyte of flash, up to like 192K of RAM. Same kind of peripherals. It's got it's got triple 2.4 megasample ADC, and you can do like 7.2 megasamples in triple interleave, which I don't really need, and dual DA and DMA and all timers and all that. Wow, there's got like 17 timers. It's ridiculous. A lot of timers. So this is like a kind of intense chip. But what I'm really looking for is like the speed, the flash, and the RAM. Mostly actually the speed and the RAM. The other stuff is not as important. But I need speed to be able to run the interpreter fast, and RAM to have as much object space as you want. And flash, as long as there's a reasonable amount, it's good. And then I also looked at, so if you look at this chip, and you look at it on Octopart, it's $9, $9.50, maybe $10. Looks like, depending on how much flash you want with it, but like about $9. Looks like Verical. They sell old stock, so maybe. Oh wait, there's multiple different sizes. Oh, I need to know which one I want, huh? Oh, I don't even know, but it looks like $7, $8 or so. And then I also compared to the chip that's using the Teensy, the Kinetis MK20DX, which is also Cortex M4, but is slower and has like less flash. So this is the Teensy 3.2 chip, but I really do like that chip. I use the Teensy a lot. And so this chip is like, 510, 550, 510 or so. And then if you compare it to the equivalent chip on the SAMD side, it's like $3.50 or $4. So it's $1, $1.50, $2 less, and it's faster and more. So I'm kind of like looking out for this. That's why I was very excited. I was like, ooh, this is going to be really good for me, because I want to get the circuit. I want to be able to sell the Metro M4 for like $20 or $25. So I can't spend $8 on the chip, because like then I have no more money left in the bill of materials for PCBs, parts, connectors, assembly cost, yield. So having the chip be $3 or $4 is important. You can't hit the $20, $25 price if you don't have a chip that costs that little. So that was like super important to me.
Okay.
Is there any questions? Or?
Nope, keep going.
Nobody cares. Okay, fine by me. So that was that so far. So I can show a quick demo.
Yeah.
So I've got the Metro M4. So we actually started by, we took it, actually, because it's almost pin compatible, we ended up taking a Metro M0 and just swapped the chip out. And then you just need to add like a capacitor and a resistor just to like, you know, make it, it's not a drop-in compatible. It's like this almost exactly, but like 2 pins are different and you have to like change the power supply a little bit. So I ended up designing a new board, and then I ended up going from the 48 QFN here to a 68 QFN. One, it doesn't matter, the space is fine, but because we use like extra pins for the flash chip, and I had the NeoPixel, and then we lose 1 pin because there's a buck converter, it ended up being like, I was actually like 1 or 2 pins short, and I don't like sharing the single wire debug pins. So I ended up just saying, look, you know what, let's just bump up to the next big size, and this one can do 1 megabyte of flash, whereas the QFN smaller one only does half. So this way I can have like the mega CircuitPython setup. And so it's cool, you know, you got the blue LED, we have the bootloader ported to it, which isn't too bad. The only big changes we made, you can look at our GitHub repo for the changes we committed. So a lot of it's just clocking, because you know you have more clocks and you're running this at 120 megahertz, so there's a little bit more peripheral management. Nothing huge, just like, you know, we had to go in and like fix a couple of peripheral setup things to get the peripherals going. But after that, the register names were almost always the same, and the registers themselves are almost identical. A lot of code just kind of worked. So this is a Blink sketch. So you want to go to the computer. So I've got the Metro M4, SAMD51. It's in a branch. And we can upload this through the Arduino IDE. While this is compiling, I'll show the SAMD. If you want to check it out, this is in the SAMD51 branch. So just go there, and then you can see, like, there's not that many commits. Like, really, Dean actually did almost all of this to get it going up on the SAMD51. And started
one question when
yeah.
you get a chance later. Can you talk about the roadmap of the M4 boards? Like, what type of boards you think you're gonna have?
I'm probably going to just slowly, you know, I'm going to start with like the Feather Express, you know, for CircuitPython, like, and you know, comes with the RAM and the flash chip and a NeoPixel, the Metro M4 Express. And then I'll probably do some more feathers. And then, you know, I was thinking about like a Gemma or a Trinket, but it's actually kind of like a challenge because they don't make the chip very small.
Yeah.
So I'd have to go to the BGA chip, and it's like a 0.4 millimeter BGA.
Maybe we'll make a slightly larger Trinket,
yeah.
Slightly larger Gemma.
I'm going to explore. That one's last. And then Circuit Playground Express M4, I'll probably make one of those as well.
Yeah,
and
like
then slowly transition
a mega-sized?
A mega, yeah, I want to make a mega-sized one. That's definitely something I want to do that we didn't do with the SAMD21 because they never made a SAMD21 with enough pins.
No.
The Cortex M0, they only had up to, I think, like this 48-pin chip. I don't think they made it. Or maybe they made one a little bit larger. They made a 68-pin one, but it was like not enough pins to fill out a mega.
Do you see SAMD51 with Bluetooth, with Wi-Fi? Do you see any of that?
I think, you know, we would pair them up like with a shield or an add-on. I'm hoping that Microchip makes, you know, takes a hint from Nordic and makes something with Bluetooth built in. But I think for the M4 Bluetooth stuff, we'd go with Nordic, which, you know, it's not out yet. So they're native USB one, but we're slowly working
so close,
on. Yeah, we're like slowly working on it. I think
native USB, Bluetooth, Wi-Fi, something M4 level. That's where it's at.
I like the Nordic, but I still want to have the SAMD51 as a possibility because, you know, if you want to put on a board, you don't need Bluetooth. It is a lot less expensive, you know, than the NRF. You're going to pay a couple dollars more for Bluetooth.
Someone wants to know a Circuit Playground Express M4 bigger with 12 NeoPixels IoT.
I don't know. I mean, I kind of like the compact size. Part of it is just like trying to keep to that price.
Yeah.
You know, it's like you can always make something bigger and more, but then it's like it never really ends. So you can look at the commits and like see the kind of stuff we did. A lot of it was just setting up like we had to include like the Simpsons files, and just like we changed
Oh, how well is PWM integrated?
I think we got PWM working. I can try it. The only thing is, I'll warn you, the variant for this board isn't done. So we like literally just got like this put together this morning, and we're like, yay, we have to do a variant, but we got tone working, DAC output, analog read, high speed. We got USB working.
Yeah.
But we haven't. I don't have everything working yet. Okay, so let me. Oops, I forgot to select the port. Hold on.
What do you want to do next?
Well, I was going to show this
Did it blink?
upload thing and then blink, and I was going to do a GPI demo, but just give me a second because I
Okay.
have to.
Yeah, we have an oscilloscope tonight.
Sometimes the bootloader doesn't kick in, or the USB is a little bit. It works. We're not sure why sometimes, like when you power it up, it doesn't enumerate immediately. All right, so this is blink. So you can go to the overhead. I'm going to show you blink.
It
Just
bangs.
blink. Okay, so that's blink, so you're good. And then let's just make it blink faster. So we'll go to 100 milliseconds between blinks.
We could say for sure this is the first time live on the internet this has been done.
The same. I don't think it. I don't even.
Yeah, this is the first time. This
I'm
is
not
it.
even convinced that Microchip has a video.
This is it right now here.
Why is it not?
All of you live
Kicking the
viewers, you're part
bootloader.
of something very special.
My computer's also really weird about COM ports. Like after, you know what? Like after all this like TI software I installed, it's never quite been the same. It's like traumatized.
Yeah.
Okay, so now it's faster. So you can go to the overhead. So now you got blinking,
Blink, 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 blink.
high speed. Okay, so it's fast. But then we're like, okay, well, it's how fast can we go? So let's just do digital writes.
Can it do cap touch?
Can do cap touch.
It can do cap touch.
It has built-in hardware cap touch.
It has built in.
And I'm 99% sure that my reverse engineered code will just work. So just use my free touch library.
It does it and it's free.
It's free. It's open source and it's free. Because I got that. That's how we got it. Capacitive touch on the Circuit Playground and an Arduino for the Gemma and Trinket. Is we have to use free touch. Okay, so now you can't even see the LED because it's so fast. So let's go to the the oscilloscope. Thank you. So let's zoom in. And then, so it looks like we can get, about 500 kilohertz. So that's just digital write high, digital write low. So that, the thing is about that is you're going through the entire Arduino core to do that. And so it's a little sluggish. So what we want to do is actually write manually. So we can do that. We can skip the Arduino stuff. And then, let me see, I have this old sketch.
Sometimes I feel like skipping the Arduino stuff.
I'm going to skip the Arduino stuff.
Sometimes I feel like
It is, I keep forgetting the exact command. Oh, it's port group 0A. So if you looked at the schematic for this, pin 13 is on PA21. So that's D13. So you can just see the schematic here. Working on this. So PA21, D13. So to set this pin high, we can do outset equals 121, and this is kind of the manual way of toggling the bits. So we'll do outset and then out clear. It's kind of nice. That's what I like about ARM chips is you have outset, out clear. You set the bit, it clears it if you set it to 1, or sets it if set to 1. So it's
Tidy.
very tidy, very clean. All right, so let's try uploading this, and then we'll look at the scope. Upload. What's funny is because the flash is so big, it's a megabyte of flash. It takes a while to erase it.
Hey.
So when Dean was working on it, he's like, he had to increase the timeout because it errored out because it was like, why is it taking 2 seconds to erase the flash? It's like you have a megabyte of flash. So let's zoom in. All right, so now we're much faster. We're about 3.7 megahertz or so over there. And one of the things you notice is that there's a spike. There's this like fast spike, and then it's flat. It's not like a square wave because once it leaves the loop, there's a loop, and so once you leave the loop, there's this Arduino management, USB management that takes over. So let's while one this. So we don't do that, and then upload this version. But anyway, we're doing quite well. Just like pin toggling, getting 4 megahertz almost.
with more and more flash, you'd eventually have to move to something like CircuitPython anyways. You don't want to be doing this all the time.
This is, well, look, one megabyte of flash means you're using like an RTOS or something ridiculous. Okay, so now we got rid of the Arduino leftover stuff, and now we're doing 8 megahertz GPIO toggles. But there's still a little bit of delay there because there's still a loop, and I guess, there's I was reading about the ARM Cortex M4, but there's some pipelining, so it takes quite a few cycles to get out of the loop. So what I'm going to do is we're going to change this to be out toggle, and then I'm going to totally just cheat. I'm going to unroll this loop. So I'm just writing a toggle, so it'll just toggle back and forth each instruction, but it'll do it a bunch and then it'll loop, so you'll see how fast the GPIO can toggle without doing loop management and stuff. So there you go. So now you can see there's the fast speed and then the delay. So then if we zoom in, we get 30 megahertz. So that's actually as fast as you're going to go because it's 120 megahertz clock. And so there's 2 cycles to pull up, 2 cycles to go down. So it's 2 cycles per GPIO. And that's as fast as you can go. Now we're spending 2 cycles to set a pin and lower a pin. But this is as low as you get. You can't do single cycle. It seems you can only do 2 cycles. But that's still very, very fast. Way faster than the SAMD51, which even at, it had a high speed mode, but the generic GPIO port access is only, I think was 7 or 10 cycles. So this is super fast. Very nice to see. Make clean output too, which I like. So that's high speed. So that's my proof that it's running at 120 megahertz.
Okay.
Yay.
What else do you want to do?
That's it, unless there's a request.
All right. Ask your questions in the chat, folks.
Yeah, we're on the Discords.
We're on YouTube.
We're on the YouTube.
Twitch, Discord, Periscope. I'll probably just upload the video to Facebook. Facebook doesn't like live broadcasting in the same way the others do.
Wow.
Okay.
That's so.
What is the purpose of achieving such a high frequency?
Well,
why would you use it?
If you're processing a lot of data, you need a lot of cycles. If you're doing, video or data analysis, if you're especially with DSP, it sounds like you could use this to drive a radio or audio devices, or even videos, small video devices. It can do camera capture, so you could do camera video processing. Like I said, it can decode MP3s because it's fast enough to do that, on the fly. For me, having the extra cycles really help with CircuitPython, because with CircuitPython, it's interpreted. So it's not, you don't get GPIO direct access. You have to go through the Python interpreter. So having a 4 times speed up really makes a big difference, because there's so much overhead when you're using an interpreted language on a chip.
Okay. Which chip are you going to put on the Circuit Playground Express?
Probably the SAMD51 G19, which is a 0.5 mega flash and 192K of RAM, but I'm not sure yet.
Okay. Do you know when do you think we're going to have some of these boards in the store?
The thing is that I did order a reel of chips a while ago, but technically they don't ship till November. So this might be a Christmas gift.
But what if everyone tweets at Microchip Makes on Twitter and say, make sure Adafruit gets some of these chips, because
you should do that.
We just saw this thing and we really want it.
You should do that, because I told them, hey, if you guys give me a reel of chips early, I'm not giving them, I'm buying them, right? I'm giving them cash money. But if I get these chips out early, we can get people developing. Because, we did a bunch of Arduino stuff, but there's infinite libraries that can be tested and different projects that people want to build. And we want to get this into the hand of Circuit Pythonistas. So hopefully, I ordered 4,000 of each chip. If you email or tweet at them, maybe we can get them to send me a reel early, because as soon as I get a reel, I'll make the hardware. Because the hardware, as you can tell, the hardware design is done.
Here's a suggestion for the name for the Metro Mega Gotham.
Okay.
Next up, we got more questions. If you're going to make the Mega format board, does the chip have the UARTs for multiple serial interfaces and enough digital analog GPIO, or by Mega do you mean larger rather than Mega to 2560 format. What do you
No,
think?
it would be like a big chunky chip, but if you look at the data sheet for the SAMD50, the SAMD51,
Can we call it a big chunky board?
the one I want to use is the 100-pin TQFP, and it's got pin count. Hold on. So this is all the pins that you get. So you just get like a ridiculous number of GPIO. I think you get like, 20 ADCs or 30 ADCs. You get those 2 DACs. Interrupts on every pin. The parallel controller, waveform outputs. You get, I think, 8 circoms on the 100-pin. I'm trying to remember. I think you get, on the big chips, you get 8 circoms. So you could have up to 8 I2C SPI serial. So that's, very, so you get 8 because there's circum 7 here. This data sheet kind of combines everything together. So it's a little bit like you have to see what's available. But you'd have definitely enough GPIO to do anything you wanted, high speeds, a lot of flash, a lot of RAM. So I think that would be really good for CircuitPython because you'd be able to build like anything.
Okay. Is there any plans to build a separate Bluetooth wing so we can pair with any baseboard?
I'm not sure yet. Maybe.
Okay.
It might be a Bluefruit, like a 51 Bluetooth. The thing is that the NR52 has Bluetooth, so like a lot of people just use that. I don't know exactly whether people really want or need an external Bluetooth device, but I am kind of getting excited to ditch the ATmega 32U4 baseboards. I mean, I'll carry them, but I really want to push people towards the M0 and then the M4. It's going to be the same price. And so much more powerful. Like, there's not really any comparison.
What's the board that might have like all the pins and functionality put out to headers or pins so they can maximize the chipset potential? Would
Probably
that be
the Mega version.
the Mega version?
It's going to be just enormous. I think it's like 80 GPIO. But there is a 100-pin version of this chip, so I can do it. And it would be like better and faster than the Due, and it would be less expensive and like not as flaky.
Yeah.
Yeah, because it would have like a more durable peripheral set. Like so far, like people using the Zero, I like using the Zero, and like I've not heard any issues or concerns with the M0 series boards.
Yeah.
Like we've kind of nailed down all the bugs, all the major libraries work. Another thing that's important is a lot of people in the community are using it. Like I see Kickstarters and projects.
Yeah.
And like contest entries that use the M0, it promotes the idea that, hey, make sure your library works with this chip.
Yeah. How can you check the difference from the last version of the ATmel chip? I guess, is there a comparison chart maybe? Or
There's
something?
not.
Yeah.
You'd have to open up both data sheets and just look at them. I mean, they might have a selection set up in on Microchip, but I couldn't quite figure it out.
Yeah.
Yeah, I just know the SAMD51 so much. I'm like, oh, this is different because they don't have this, and yeah.
Yeah. Sorry, the YouTube chat was like down, but it's back.
Okay.
Sorry for the folks who didn't get your questions answered. Just type them again in YouTube chat. Sorry. Does the bootloader for the SAMD51 exist?
Yeah, it's the same bootloader we use for the G18. It's
Okay.
actually the E18 and the G18 is the same chip, just one has less pins.
Next, what Arduino boards can run CircuitPython? The M0 ones.
Right now, all of our M0 baseboards can
Yeah.
run. So the Metro M0, the Feather M0, the Express boards, the Trinket M0, and the Gemma M0. Trinket M0 is coming out soon. The Gemma M0.
What's the tweet handle again? At Microchip makes.
Yeah, Microchip makes.
I'll just be like, hey.
Hey.
It's at
He's gonna like exert a little bit of peer pressure. I know. I think they're getting me the wheel as fast as they can. I don't think.
Use the social media.
I don't think. Well, but it's good to tweet at them anyways because then they can have like engagement.
Yeah.
Can connect with the brand.
Is it possible to run Python on Arduino Uno? Not really.
No, you cannot.
Not
You need at least 16K of RAM. There's absolutely no way to do it with less. And that's the NRF51, and it's like it works, but like it's really minimal.
There's like a
32K is like
sorry, folks.
necessary. 16K is like bare bones.
Yeah, there's no boards made by Arduino CC that runs Python right now.
Is that true? The Arduino Zero we don't have a port for it, but you could make a variant for it.
Yeah.
And try. We don't like support it, but you could on the Arduino 0.
Yeah.
I think. Yeah, I think you could. But you wouldn't get like the file system management because you wouldn't have the SPI flash and stuff.
Yeah, if you had questions in the YouTube chat, just post them again because like YouTube was acting weird. Okay. M0 M4 boards have a combined HID keyboard and mouse library like the 32-4 boards.
Yep, the M0 does already, called pluggable USB, and I think the SAMD, the 51, it's something on our list. It will work. I'm not worried about that because we've got USB serial working great. The bootloader works great, so USB is like working. It's just a matter of just checking to make sure that all the setup is correct.
Are the two I2C bidirectional audio? The chip would be great for audio filtering.
It does I2S, and yeah, I believe there's just two totally separate. Let me check. It says I2S. Yeah, there's two. Looks like there's two
70.
bidirectional ones. There's RX0, RX1.
We linked to this datasheet, by the way.
TX0,
on our blog
TX1.
post.
Yeah. I believe there's two full I2S peripherals. I mean, there's two I2S peripherals on the SAMD51, but it's common to have two. So you can do like bidirectional.
Do we have any dev boards with any Cortex A?
Oh, is that the FPGA thing? I don't know of that, but I know that there's a couple weird Cortex chips. Unless you mean like this 7 series, the ones that like run Linux. There's the only ones that I've really worked with are the M0s through the M4s at this point.
Microhex says technically the Raspberry Pi 3 is a quad Cortex A5 III.
Oh yeah, it's this just the bigger chip, and it runs very, very fast. Like the Cortex line runs from the M0, which is pennies and low speed, up to running your phone or running a Raspberry Pi.
Someone wants to know which has more features. I do Arduino IDE or Arduino Create. Arduino IDE right now, because Create is
right now the
web-based.
IDE is more featureful because you just have the desktop software. You can do more.
Yeah, someone said they want to run a 3D printer using a mega-sized Metro. Yeah, that'll solve.
Oh, like a mega-sized Metro M4 would be amazing for 3D printing.
Yeah,
it would be so fast.
Okay.
Although, do you really need is it because you need? Is it because you need the pins? Maybe it's just physically. Yeah, if you need the pins, then yeah, because if it's just speed or flash, the Metro will do it. But I think you probably need like
a bunch of 3D printers used to run megas.
Yeah, they were like ramps boards. It's been a long time. You could probably run it all in Python, which would be ridiculous, but you could do it.
Are we and Arduino friends again? We were never not friends.
We're friends with everybody.
Yeah, we weren't. We didn't know the former CEO that well, but he's gone now.
He's not inviting us to any parties, that's for sure.
Yeah. I actually emailed with Massimo and Arduino today and during the week. I congratulated them on their successful reclaiming of their company.
Here's a good comparison chart. Let's look at this. So this is the comparison chart. So yeah, I want to go with like the SAMD51N, which is a megabyte of flash, 256K of RAM, 100 pin TQFP. It's really small. And then for the mega-sized one, and it has 8 circoms, 8 timers, 2 compare channels, and then like 2 or 3 more other compare channels. It's I2S, USB, 2 SD card slots, 14-bit parallel capture, and then it has 81 GPIO pins. And there's one with 99 GPIO pins too. Has 16 ADC channels on one and 12 channels on the other, so it's a total of 28. Lots of capacitive stuff, and then tamper pins. I don't know what that is, a security thing. But yeah, it's good. It's gonna be plenty. We good. I like it. So yeah, the smaller ones have 6 circoms, the big ones have 8. Good circom time.
Okay. Let's see what else. That's everything.
Yeah. Okay. Cool.
All right. Well, we'll have Ask an Engineer tomorrow. I'll be wrapping up my.
Yeah, I'll chat about the same things a little bit.
Yeah, I'll be wrapping up some Arduino news, a bunch of other news, a bunch of other stuff.
I could try to do it analog right with this.
You want to do it?
Well,
right.
somebody asked, and now I'm kind of like, I think it works. So maybe I'll do this. And then analog right LED I.
The Mega footprint has a lot of free space. Anything go in the middle? SD card.
Yeah, I could probably put SD card, and maybe it would have an SPI flash, SD card, NeoPixel.
Yeah.
I don't know what else. Like, there's physical space, but I don't know if I want to. I don't like to add tons of extra add-ons for like no reason.
Yeah.
SD card's pretty inexpensive, and you can get ones that flip up, so it's like not in the way.
Wi-Fi.
Yeah, just add Wi-Fi. Okay, so let's look at. Oops, sorry. Why did I open USB? So let's look at the
Scope.
scope. Let's see if PWM works. Oh yeah, it looks like it works. It's like really fast. Let me add a little bit more delay. So yeah, we did get PWM working.
Put a bottle opener on it.
A bottle opener?
Yeah, bottle opener.
Why would I put a bottle opener on it?
Oh, for the millennials.
Oh, on the Mega, yeah.
Yeah.
I could put like some cool art.
Yeah.
Cartoon characters maybe?
RFID antenna.
Yeah, I could do RFID. Okay, yeah, so now I've got PWM going. So you can see. So yeah, we got PWM output on this, and then we got the dual DAC working, although there's a bit of an errata on the dual DAC. You have to connect AREF to 3.3 volts, which is a little bit weird. Silicon A rev, probably fix Silicon B rev.
Yeah.
But there's PWM working. So yeah, I mean, we got the basics working with stuff. So we'll get it all cleaned up a little bit more, and then ship it probably October, November, as soon as I get chips, and maybe people can help make projects, try it out, hack on things.
Yeah, so get ready, everybody. Check out the GitHub. Check out everything that's going on. We'll be doing Ask an Engineer tomorrow.
Yay! Show and tell.
Show and tell, and Noah Pedro, and all this stuff is going on.
Yes.
To play us out tonight, I have a 30-second clip from 9 Inch Nails. We went to 9 Inch Nails on Sunday.
My goth boy.
It was good. So we'll play ourselves out. We were just watching it.
Bye.
Bye. Bye, everybody.